Okay, so if no doubts, let's begin a discussion from Venn diagrams. A Venn diagram is a visual way to show relationship between different sets. It uses overlapping circles to represent each set. The areas where the circles overlap, like when they overlap this area, show the elements that are common to both the sets. So this is the area where whose elements are common to both A set, both B set. Each circle represents a set. This circle represents a set A. This circle represents a set B. The overlapping area, the intersection of circles, shows elements common to the sets, both of the sets. Non-overlapping area, the parts of the circles that do not overlap, like this and this, that shows elements which are unique to each set. In this case, there can be cases like, let's take one as, let's take A as 1, 2, 3, 4, B as 3, 4, 5, 6. So 3, 4 are the common elements. So 3, 4 will be lying here. And here, which are the elements which are unique to A are 1 and 2. And which are the elements which are unique to B are 5 and 6. Okay, like this. So universal set. Sometimes a rectangle around the circle represents the universal set which contains all possible elements. Let's consider that these two circles lie in a rectangular region, and this rectangular region it represents that it is a universal set. And let's call the universal set that it is having all the natural numbers from 1 to 10. Okay, so something like this we can represent the universal set as. So are you able to understand what is Venn diagram first? What is this rectangular cardboard and what are these two circles? Clear?
Yes, sir.
Yes. Now let's discuss about. So what we are doing now, we are representing the set using circles. Like we were drawing a rectangle, we were calling it as a universal set of which other sets will be, which are concerned to us, will be the subset of this. All the sets will be subset of this universal set. So let's take one set as A, another one as B. So union means that, let's take a set one A as 1, 2, 3, 4, set B as 3, 4, 5, 6. So set A is what? It is a collection of some data, well-defined data, set B is also a collection of some information. When we combine both of the information in a single set, then we call it as a union of both sets. And it is denoted by U. Okay. And it is represented by U. Union of sets. Like if we have to take union of A and B, how we will write? A union B. So this particular set now is a new set, which is the union of set A and B. That's how it is represented. So if we take union of 1, 2, 3, 4, like set A and set B, so we will include 1, 2, 3, 4, and plus also the information which is given, or plus also the elements which are left in set B. So 3, 4 are already included, so no use of repeating them again. So taking 5 and 6 in the union set. So our union set will become 1, 2, 3, 4, 5, 6. Is that clear, everyone? Any doubts?
No doubt.
No doubt, sir.
Okay. So let's take an example. Let's say a set C consists elements A, omega, theta, and set D have elements omega, theta, phi, or beta. Okay. Now you tell me what will be the union of both sets? What elements will be in the union of C, in the union of set C and set C and set D? Please, anyone?
Sir, omega.
What will be its union? Union of set C and D?
That's what omega and theta.
Omega and
Theta.
only two elements.
Mm,
When we are like taking union of sets, so we have to utilize all the
okay.
information. We have to
Then,
combine both. Then
then alpha, null, and beta. What is the
this is
first one?
this is
A.
okay. This is
Okay.
alpha.
Okay.
So omega, theta, and
Alpha, beta, and even null too.
this one.
That one.
Good. So how many elements were common here? 2. So 2 plus 1, 3, 3 and 2, 5. Yes, there are 5 elements in C union D. Okay. So this is how we find out the union set of two sets. Clear?
Yes, sir.
Let's now discuss about intersection of two sets. So in intersection, basically, we find out the common elements in both sets. In this case, 1, 2, 3, 4, and set B 3, 4, 5, 6. The common elements are 3, 4. So we are just going to find the common elements and going to write A intersection B, this only 3 and 4 only. And this is the overlapping area between two circles. Like if we write this is A, this is B. So this particular area, this shaded region is the common area, right? So this area is represented as A intersection B because it is an intersection of both the sets, right? If we have to, this is A set, this is B set. We have to find the union of both sets. So intersection will be included and plus all other set because we are combining and utilizing all the information. So this whole shaded region is the A union B region. Clear?
Yes, sir.
Is that clear? What is intersection of set A and B?
Yes, sir.
Should I repeat? No.
No, sir. Clear.
So let's take one example. Let's take set C as set of natural numbers. Let's take set D as multiples of 2. So multiples of 2 are okay. So now we have to find out the intersection of both of these sets. How we will find out? Set
But
of natural numbers.
then multiples of 2 is C intersection D.
Okay, yes, but how we will find out? Like, what are the elements in set C?
It starts from 1, 2, 3, 4, and it goes on.
Yes. And what are the elements in set D?
2, 4, 6, 8, and like 10 goes on.
It depends if we are considering that we are taking multiples in, like we are multiplying positive integers only. So yeah, we can consider negative values as well. -8, 6, -4, -2, and then 2, 0 also, 4, 6, 8, and then plus n.
Then C intersection D will be set of positive multiples of 2.
Right. Very good. Very good. C intersection D will be 2, 4, 6 plus infinity. So this is basically, if we have to represent this in a set builder form, so we will write set of two of x, where x belongs to natural numbers, right?
Hmm.
So union done, intersection done. Now let's talk about difference between two sets. So, this is simple, like simple definition. Elements in set A, but not in B. So all the, if we are finding set A subtracted by set B, so we have to write all the elements that are in A, but that those but not in B. So we have to find out the set of elements such that they are present in set A, but they are not present in set B. So whatever there is present, in set B will not be considered. That is 3 and 4. So basically, this will be 1 and 2. This is the part of a circle that does not overlap with circle B. So basically, what we are finding when A minus B, considering this is a set A, this is B. So finding set A's elements which are not in B. So we are taking all the elements which are lying here, excluding the intersecting elements. Understood? There
Yes,
were
sir.
three. There are 3, 4 in the intersection, and here 1 and 2. So only 1 and 2 will be considered. And here 5 and 6. Clear?
Yes, sir.
Please understand this. Sometimes we misunderstand and we think that A minus B should be equals to B minus A, and that is not the case here. Let's take a different example. Let me ask you a question. This is A minus B. Okay. So what if we have to find out B minus A? What is B minus A?
Is it 5 and 6, sir?
Yes, very good. 5 and 6. 5 and 6 are those elements which are present in B but not in A. Clear?
Yes, sir.
B minus A means elements which are in B but not in A. So A whole will be excluded and the remaining elements in the B will be written. So this is B minus A. That was A minus B. This is A minus B. It's B minus A. Are you able to understand the Venn diagram concept? How am I writing, drawing these drawings and circles? Is
Yes,
that
sir.
clear? Great, great. So let's now discuss about symmetric difference. This is also very easy. Now let's understand one thing more, that whenever we are finding A minus B, so what we are doing, we are like taking the A set and we are excluding the intersection of both, right? We are taking the A set and we are excluding the intersection of both sets. So if we have to find out the cardinality of this particular set, so we can write in this manner. This is a formula. Okay, don't have to write right now. Slides will be provided in that, it will be mentioned very clearly, but you just have to understand that how it is formed. The cardinality of set A minus B is n of A minus n of A intersection B. Clear?
Yes, sir.
Yes. Let's also find out the cardinality of n of A union B. So all we have to understand is by using the Venn diagram concept, just a universal set A, set B, A, B. When we are taking union of both, so we are including everything, whatever there is in the two sets. So what we are doing here is that we are taking n of A elements, and we are also taking all the elements of B. But now, when like there are two sets A and B, we have taken the whole circle once, the another circle also once. But now we understand that this particular region is counted twice, right? Are you able to understand that this particular region, which is A intersection B, is counted twice?
Yes, sir.
That's why we will subtract it once, because it was counted twice. Now we will have original cardinality of A union B. That's how this formula is written. Very important. This is basic, so that's why it's important. Clear?
Yes, sir.
Yeah. For the formula, the cardinality of intersection of sets, we'll use the same formula because it is the cardinality of intersection of sets. We'll bring this to the left hand side and this to the right hand side. We will have the formula. Okay.
Yes, sir.
So union, intersection, difference done. Let's understand symmetric difference between two sets. So symmetric difference, you will be able to understand it very easily once when the diagram is drawn. Considering this is a set A, this is a set B, and symmetric difference when diagram is like this. You are taking all the elements of set A or set B, but there should be no elements which are common in both. They must be unique in both of the sets. We are excluding completely the intersection part. So elements in A or B, but not in both. Okay, they should be very exclusive for but both of the sets. So in this case, 1, 2, 3, 4, 3, 4, 5, 6, 3, 4 are the elements which are common. Okay, so we will only take 1, 2, 5, 6. So 1, 2, 5, 6 is the answer. And also, what are the elements here? 3, 4. What are the elements here? 1 and 2. What are the elements here? 5 and 6. So we are not considering 3 and 4. So only these elements will be considered in this set. So A delta P is 1, 2, 5, 6. Is that clear? How have I drawn the Venn diagram and represented the set?
Yes, sir.
Great. So these are the parts of the circle that do not overlap. So this is the part of the circle which do not overlapping. The overlapping circle is that we are not considering. Is that clear? Symmetric difference?
Yes, sir.
Now for the cardinality of this, what we are actually doing is A delta B is also written as we are combining both A minus B and B minus A. What is A minus B? What is A minus B? Look at here and now tell me what is A minus B?
1, 2.
1, 2. Very good, very good. So this is A minus B, right? And what is B minus A? 5, 6. So we are combining both of these sets and we are calling it as symmetric difference of A and B. So the if it is so, the cardinality of this particular symmetric difference set should be inclusion of what are the sets? How the number was find out? N of A minus N of A intersection B plus N of B minus N of A intersection B. So it will become N of A plus N of B minus 2 of N of A intersection B. Sorry for my bad handwriting. N of A plus N of B minus 2 N of A section B. Is the formula clear to you? That how have I written so?
Yes, sir.
Yes. So here also if we apply the same formula, N of A is 4 plus N of B is also 4 minus N of intersection of B. 2 into what are the elements which are common? 3 and 4. So there are two elements such. So 4 plus 4 minus 4 becomes 4. So there should be 4 elements in symmetric difference of both set A and B. So yes, it is the case here. Clear? Clear?
Yes, sir.
Yes. So this is symmetric difference of both sets. I'm enjoying this tool. This vanishes itself. Okay. So please observe the diagram. The overlapping uh, reason is not included. Okay.
Yes, sir.
Yes. And let's discuss about complement of set later. So just observe this for a while. Here,
Yes, sir.
back to our slides. Venn diagram. We have already discussed about that the rectangular region is the universal set. The circle is representing our set. Union of sets, let A and B are two sets, then union of A and B is generated by A union B. A union B, and it consists of each one of which is either in A or B, or in both A and B. So we are just unifying all the information which is there a little bit there. Just understand the Venn diagram and it will be very clear to you. So it is bookish language, you can refer to it, but you will be better understanding it after solving some questions. Let's take an example where set A and set B is this. So then the value of A union B will be what? Please tell me which option is correct here. We are unifying all the information from both of the sets. Yes, Tanish, please answer. Yes,
Sir,
yes,
is
sir.
it
Sir, option B.
Okay. Okay, my laptop is back. 1, 2, 3, 1, 3, 5, 7. So 1, 2, 3 should be there. Yes, 1, 2, 3 is there. 1, 3, 5, 7 is there. 1, 3, 5, 7 is there. Yes. There are no extra elements. Yes. So this is the unit set, union of both of the sets. Now let's discuss about intersection of sets. The sets which are common in both of the sets. Simply this bookish language. And if like there's an element not belonging to A intersection of A intersection B, so it says that it means that whether X is not belonging to A or X is not belonging to B. So it's a or condition here. Okay. If some element is not in the intersection of both of the sets, so it means that it is unique to A or unique to B. The shaded part will represent this. Okay, and A intersection B is the subset of A. A intersection B is a subset of B also. So if A is 1, 2, 3, 4, B is 2, 4, 6, then please tell me the value of A intersection B.
option A?
Very good. Yes. Disjoint sets. So this is the case when two sets A and B are said to be disjoint sets if they have no common elements. If they don't have any common elements, they will not overlap or they will not intersect each other. In this case, A intersection B is a null set. Clear?
Yes, sir.
That is, sets can be represented by Venn diagram as shown in the figure. So here A is 1, 2, 3 and B is 4, 6. So there are no elements in A intersection B. That's why it will be written like this. And this is like known as phi, which represents a null set. Clear?
Yes, sir.
Difference of set we have already discussed about it. If A and B are two sets, then their difference is a set of all those elements of A which do not belong to B. If an element belongs to A minus B, it is the condition. It says that particular element is belonging to set A and not to set B. So this is the element which is belonging to A minus B set says to us. In the figure, the shaded part represents A minus B. And for B minus A, you can also see the event like this. In the there is a I hope you have not seen it. Now tell me, what is A minus B? First, tell me what is the set A minus B here?
Um, 1, 9.
Good memory. Why 19?
Because 3, 5, 7 is also in B, no, sir. So
Yes. Good.
1 and
1 and 9. And what is B minus A? This time, Tanish.
2 and also.
2 and 11. Why 2 and 11?
So because 3
Why
and 5
2?
and 7 are in values are in A.
3 and 5 and 7 are?
The numbers are in set A, so they will be minus.
Huh? Sorry? When we find B minus A, so the set of all those elements of B that do not belong to A. So all those elements of B which are not belonging to A. So 357 also belongs to A. That's why we'll exclude 357. Maybe you were giving right answer. I was not able to understand it. Okay. So that's why 211. Clear?
Yes.
Clear?
Yes, sir.
Symmetric difference. So it is the union of A minus B and B minus A. Yes, it is the union of A minus B and B minus A, where the element must not be belonging to A intersection B. We have already discussed these. Now let's take this example. Now, who's going to tell me the answer?
Option B, sir.
Option B. Okay. 1, 3, 5, 7, 9. 1, 2, 3, 5, 7, 11. So basically what we are doing is we are excluding the common elements. We are taking all the elements. So what are the common elements? 3, 5, 7, 3, 5, 7, 1, 9, 2, 11. Yes, 1, 9, 2, 11 must be in the set. That's why B answer is the correct. Clear?
Yes, sir.
Good then. Let's go ahead. Complement of set. So it is basically nothing, just let's take a different example. Oh, magic. So let's consider this is the universal set. This is the universal set, and this is a set A. Magic. Yes. So this is set A. Now if we are like if we are saying set A, so it means this yellow region. Which yellow region? This yellow region. If we are saying complement of set A, it means that we are excluding set A and we are including whatever there is in the universal set. So it means this pink region. Okay, and set A is this yellow region. Okay, so complement of set A. Complement of set A means that basically we are subtracting set A. We are subtracting universal set from set A. That is complement of set A. Okay. In universal set, we are excluding set A. That is the universal set. That is the complement of set A. Is that clear?
Yes, sir.
Oof. Okay. So if U is a universal set and A belongs to A belongs to universal set, then complement of set A is denoted by A dash, A dash or A raised to C also, or U minus A. What we were doing here also, U minus A. Now in this universal set, if we are taking the complement of set A, so basically we are taking everything in the universe except the set A. Okay. This is also written here that A dash is U minus A, where X says that X is belonging to universal set, but X should not be belonging to set A. That is the complement of set A. It is clear that if X belonging to A complement, that means that X is not belonging to set A. Clear? Is this clear everything? What is a complement of set?
Yes, sir.
Yeah. So let's now discuss about the complement of universal set. So let's discuss this one by one. Drawing a drawing first. Let's take so say this is a rectangular universal set. This is a universal set, and universal set is like universe for us. For our like whatever our discussion is regarding, so universal set will have it all. Will have it all. Everything. So if we have to take universal sets complement. So how we will take so? What is the formula of the complement of a set? U minus A.
U
So
minus A.
U minus U. So what is left? Nothing. Empty set. So the complement of universal set is the phi itself. It's a null set. Is this clear? First point.
Yes, sir.
Yes. Okay. So let's now take the complement of phi set. Phi is an empty set, U minus phi. So if we subtract nothing from the universe, what is left? Universe itself, right?
Hmm.
If we subtract nothing from the universe, if we extract nothing from the universe, what is left? Universe itself. So the complement of phi set is universe. Is this clear?
Yes, sir.
Now it means that first we are taking, let's discuss about A complement, which is U minus A. Okay. Now we are further complementing it. So if we have to complement it once again, so what we are doing, U minus A of complement. So U minus A of complement is what? U minus minus plus. So you cancels U. That's A complement itself. No, sorry. A complement is U minus A. So U plus यहाँ पे A आएगा. We write it. So U minus A complement was what? U minus A. So U minus U plus of A. So what is there? A. So if we complement any set twice, so the set itself will come out. Is this point clear?
Yes, sir.
Yeah. So let's understand this point from the previous diagram. This is the pink region is what? A complement. This is yellow region is A. If we take the union of A and A complement, so what is there in totality? If we take A also and the A complement also, what is there? We combine both of pink and yellow region. So what is this rectangular representing? Anyone?
Mm.
Go back to the discussion when we were discussing about Venn diagram. And so what the in the Venn diagram, what the rectangle was representing?
Universal.
Yes. So if we combine the complement of A, set A and set A itself, so universal set will be the answer.
Okay.
This is the property here. And if we take the intersection of set A and set complement of set A, so what is common between pink and yellow here? Let me ask it differently. This is A complement, the shaded region. Now tell me, what is common between the shaded region and unshaded region? Nothing, right? There's
Yes.
nothing common
There's
between
no
shaded.
intersection.
Yes, right? So 5 will be the answer.
So now, what did you call that actually? Like the answer, what you will say that?
Phi. This is phi.
Okay, sir.
Whether this is null set actually, but the
Um.
symbol itself is called as phi.
Okay.
Yeah. So this is clear. This is clear. And please try to understand it from a perspective of Venn diagram. You'll be able to solve all the questions of sets if you just draw the Venn diagram correctly. Okay.
Yeah, sir.
Now let's discuss the laws of algebra of sets. Okay. Idempotent. Okay. Let's now discuss about idempotent laws. Wait a minute. Okay, let's now discuss the laws of algebra of set. So algebra is what? Algebra is the discussion of quantities where we add, subtract, multiply, divide. We basically operate on sets. So now we are discussing about the laws that how we can operate on sets. So idempotent laws. Considering that there are three sets A, B, and C. So idempotent laws say that if we unify set A with set A, what is left is set A, of course. If we take take a cobalt between set A and set A, what is left is set A itself, of course. Right?
Yeah, sir.
Should I need to explain it? Like take A as 1, 2, 3. 1, 2, 3. And another set A also 1, 2, 3. So if we take
It's 1, 2, 3 only.
yeah, that's the case. Let's take identity laws. So if we unify A with nothing, then what is left? A itself. If we take common from A and the universal set, what is common in A and the universe is A itself. Like it's the universal set. The set A. If we unify set A with nothing, so set A is it. because we are unifying nothing in the set A. So if we are adding nothing to the set, some set, what is there is set itself. But when we talk about the set A and the common element between set A and the universal set, so what is common is this region. What is this region? Set A itself. Is this clear? Is the second point clear?
Yeah, sir.
Identity law clear? Yeah. Let's talk about commutative law then. If we unify A with B, so that is similar doing unification of set B and set A. It's the same. If we take intersection of set A and B, so it's the same of doing it is the same when we do intersect set B and set A. Okay. It's like A cross B is equals to B cross A. But it is not the case with A minus B. If we are subtracting two sets, so they are not commutative in nature. Clear?
Yes, sir.
And I just now written A in A cross B equals to B cross A. So this is like a Cartesian product, which is also not equal. I have written that particular property with regarding to numbers, because 2 into 3 is equals to 3 into 2 in that regard, not in the Cartesian product method. You will get to know about Cartesian products further in the chapter discussion. Okay, so commutative law clear. Associative law says that unified A and B, if unified further with C, that is the same if we unify. Uh, okay, they've written it wrong. Should be written like this: A union B is similar of writing if A is unified with B union C. So A union B is this. Okay, why I'm doing that much harder? Okay, so this is A. Take this is B. No, and we have like there is set A union B. So A union B, and this is further getting unified with set C. Set C. And let's take set C's color as this format. So this is set C. So it is similar to saying that if A is getting, let's take A. If A is getting unified with set B, and set C. So set B and set C are unified in the beginning. Set B and C, and A set now is getting unified with the remaining. So both are similar, right?
Hmm.
What is similar is the region covered by them. So the shaded region both are similar. The color is only different, but doesn't matter, right? Okay. So this
Yeah,
is a
sir.
associative law, and same goes with this also.
So,
If we
like,
are
how
taking
they will be asking questions based on loss?
no, no, it's actually used when we solve NCRT questions, and we write in brackets like square brackets that are using commutative law or this or that. But still, I'm explaining because it is there in the syllabus, and
Oh,
also commutativity, associativity. This is very common when we will also discuss about matrices. We will discuss the same properties again. So it's like the same in all of the mathematics. So it's better to remember these terms.
Okay, sir.
Yeah. So associative laws. Let's focus on this. B intersection C. So this is B, this is C. What is the intersection of B intersection C? Is this intersection of A. So this is set A. What is the intersection common here? Is this. So this is our common answer. Now let's discuss about A intersection B. So A intersection of B is this reason. This this convex lens. Now intersection of C further. This is set C. So what is there in the discussion right now is this much only. So both of the regions, smaller triangle is similar. So it's common. It's the same. What is the same? Let me rewrite it. This particular region. This is the same. So that's why associative law works here also. Now clear?
Yes, sir.
Distributive laws. So A union. Basically, what we are doing is in this from earlier like 1, 2, 3, 4. 1, 2 was a little conceptual, very basic. Third and fourth are just simple. Just we by property itself we can understand what is written. Now let's discuss about distributive law, where okay, so we have to use some space. So let's do it on the next page. So let's discuss about first property, A union of B intersection C. We have to prove this property. So what we are going to do is we are going to draw its Venn diagram and its Venn diagram, and we will see whether the end result is same or not. If it is same, so our property stays true. Time is limited. Circle set A. Okay. Set B. Set C. Okay. And similarly, set A, B, and C are going to remain the same for that also. So let's utilize our method by copy pasting undesirable. Now B intersection C is what? B intersection C is this gray region. This is the B intersection C. Do you agree?
Yes, sir.
So now after finding this particular set, we have to unify it with the set A, whichever is there. So set A is this.
Sir, one doubt.
Ah,
The small, okay, you've colored it into pink. Okay.
okay. So this is set A, and plus this gray region is our answer. Like pink and the gray region is our answer here. Okay. P plus G, you don't have to write it like this. I'm just representing the answer. The shaded region is our answer, is the result of us. Okay.
Okay. Yes, sir.
Now let's discuss about the this result. A union B is what? This is A unified with B. Okay, this is A union B plus A union C. A. Yes, I have done a
A
mistake. Right.
intersection C. Oh,
हाँ intersection है यहाँ पे, intersection here. So intersection magic. So A union B, and also you have to take a
It's actually in the question A union C, no sir, but you have written A intersection C.
where? Oh, here.
Ah,
Yes, yes. One more mistake. Yes, now we have to this, like this is the A union B region, and let's take one more example. Give me space code. Now A union C. So taking A set completely and C set completely. So this shaded region is A union C, and we have to take this particular shaded region is A union B. This particular shaded region is A union C. We have to take the common of both. So if we try to find out the common in between these two is what? Basically, no, bad decision. So what is the common in between both? So set A is completely common. Yes, this is common. This whole set A
hmm.
circle is common, and this this is also common. This set A completely common, and this particular part is also shaded in both. Okay. Okay, so this is wherever I have shaded black is common. So if it is common, let's shade it differently with a with this color, with this baby pink color. Let's take blue color. So here, 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 here. So you my doodling, that's why. Let's undo my doodling on the figure. So what is common? This, and this. So this blue region is the answer figure, and which is similar to this. Is that clear? Both of the answers are coming as same.
Yes, sir.
Yeah, that's why this property stays true. And now I'm not going to draw the another figure because it's time up for the class. So basically, how to remember this particular property is that we are just take A and union B once, and A union and write first A union and B, and then write this. Then write A union and C. That's the way to remember it. Clear?
Yes, sir.
Same goes for the property B. Property B, that write A intersection A intersection B, then write this particular symbol between both of these two sets, and then write A intersection C here. Clear? This is how you will remember them.
Yes, sir.
Okay, and it's an homework for you. You can also try making rough diagram like this, and try to solve and prove this property. You will be able to understand it in awesome depth.
Okay, sir.
Okay, so any doubt?
No, sir.
Okay. I'm having doubt on my laptop. Anyways, I'll fix it later. So let's conclude our class. If no doubts, okay.
Yeah, sir.
Thank you.
Thank you, sir.
Jai Hind, sir.
Jai Hind, sir.
Jai Hind, sir.